Welcome everyone, my name is Craig Otto. This is Statistics for SPC, Operational Excellence, and this is the second part to the normal distribution discussion. This part will be semi-quick, but it's a very important concept. We're going to talk about and look at taking raw data and translating it back to the standard normal curve into something called Z-scores. It's really just a basic calculation, but again, it's very important. And again, we're trying to take statistics that we have and translate it back to the standard normal curve. And if you remember, what's nice about the standard normal curve is the mean is 0 and the standard deviation is 1, and then that's where we can tell all those probabilities about it from the previous lesson, where 50% lies on each side. You have 68% within plus or minus 1 sigma, 95% within plus or minus 2 sigma, and 99.73 within plus or minus 3 sigma. And when I say the Z-score, what that does is it'll translate it back to the standard normal curve. So when you have a value, a data point, you subtract the mean from it. That mu is the mean, and then you divide it by the standard deviation, and that'll give you a number. That's called a Z-score. And what it does is it translates right back to that standard normal curve. And I'll give you an example here. So again, Z-score kind of represents standard deviation from the mean. And in our case, I'm going to say our normal average is 8, and our standard deviation is 0.5, excuse me. And I have a question. How many standard deviations is 6.9 from the mean? When you look at it on a curve, 8's in the middle. Here you have your standard normal curve. Or excuse me, this is just a raw data normal curve. Or I don't want to say normal curve. It's just a raw data bell curve of a mean of 8. And what the trouble is I know 6.9 is less than 8. But where does it fall in terms of the curve? Is it way out here? Is it really close to the mean? I really don't know until I do a calculation. And that's where this Z-score comes into play to kind of place where it is on that curve. So what we'll do is the X, in this case, is 6.9. We'll subtract the mean and then divide it by the 0.5, and you come up with a negative 2.2. So when you do that, now we can place that 6.9 value. So you come out negative 1 standard deviations to the end of the blue, go out another standard deviation to the end of the green, and that's negative 2, and then it's negative 2.2, so it's just left right into the red. That's where 6.9 falls. So we kind of know where it's at in relation to the mean. Now I have many different examples here that I'll run through, and I'll kind of show you. I always think it's important to draw a picture, and the pictures to the right is my effort to do that. And what I've been doing is I've been using the formula for Z-score. So first I have the given. I have the mean and then the standard deviation. So what I do is I take 20, which is how many standard deviations is 20 from the mean. So 20 minus 19, which is 1, and then I divide it by 0.7. It comes out to a 1.43 Z value. So you basically have to place it then, on your curve. So a Z of 0 is right in the middle. That's like your mean. 1 falls between the blue and the green here. That's where the line is made. 2 would be between the green and the red, but I'm at 1.43, so I'm about halfway between the green. Next example, if you have 86.5 as your mean, basically you have your X value of 71.2. So you take 71.2 minus 86.5, divide it by your 6.9, you come up with a negative 2.2. So you got to place that. You got a -1 here, a -2 between the red and the green, and then it's less than 2, so you got to keep going left. So it's just right in that area in the red. Next example, you have 26.9. You want to figure out where that is in relation to the curve. So you take 26.9 minus the 27, and then you divide it by the 1.1, and you get a -0.1. So it's almost right at the center. It's almost at the mean. So you can see where I drew my arrow. Alright, next we want to know 21. Where's 21 in relation to the mean of 16? So we subtract those, divide it by 4, and we get 1.25. So just on the other side of the blue, we have 1.25. So that's where that's placed. Next example, we have 1500 and 1425. We want to know where's 1425 compared to 1500. So you take those, subtract them, divide it by your standard deviation, which is 50, and that comes out to a -1.5. So you kind of place your arrow. That'll be in the green here, halfway through, because blue to green represents -1 there, that line, and then green to red would be -2. So that's a little bit too far, and we want to be in between those at -1.5. Alright, and then the last example here, kind of tricky numbers, but you just follow the process. Don't be afraid of the numbers. You take your x value, which is this 0.0069, subtract your mean of 0.01, divide by 0.001, and you end up with a value of -3.1. So that would be out here kind of far to the left at -3.1. So as you notice, the negative values fall to the left of the curve, and I should say fall to the left of center of the curve, and then right of center will be your positive values. And next we'll get into more detail on what we kind of do with the z-scores and why it's important in the next part of normal distribution.